For this particular problem, it says the standard enthalpy of formation, delta HF, for barium oxide is minus 553 kilojoules per mole. The standard enthalpy of formation of barium, well, not that we have to know the names, BaO2 is actually, this one's actually barium peroxide, is minus 634.3 kilojoules per mole. Calculate the energy in kilojoules when 43.5 grams of barium peroxide is reacted. So this is actually a two-step problem. So the first step is find delta H reaction, just like we did in the last problem where we write the delta HF values. And then 2 is going to be do stoichiometry using mole-to-mole ratios. As we will say. So, the delta HF values, which are typically on this list right here, so, but they weren't on the list, so for this one, there's barium oxide, but I don't have barium peroxide, so I actually gave them to you in the problem statement. And this is another option for the exam. So, but my process for doing step 1 is to write the delta HF values under each of them. So barium oxide is minus 553.5. Barium peroxide, BaO2, is minus 634.3. And oxygen, which is not given, oxygen we do have to go to that list for. Oxygen, right here, O2 gas is 0. And so yes, we can ask you to use that sheet. So just like before, delta H reaction is coefficients times product. And then, well, this is 1 times 0. Which you don't have to show if you did this for the homework. But the important thing is it's minus whatever, subtracting off whatever the reactants are times their coefficients. I think so. And we'll get 2 times the minus 553.5. Let's see, where can I put this? There we go. 2 times 553.5 minus 2 times negative 634.3. And I get 161.6. units of kilojoules per mole. So that's the first part. For the second part, we are now going to say, well, we have the grams of barium peroxide. We can, whenever we're given grams, we can convert that into moles. And I need my periodic table now. So barium is 137.3. 137.3. And each oxygen is 16. So I'll take my 137.3 plus 16 times 2. I get 169.3. And I typically do all my molar masses to 2 decimal places. The second place didn't show up because it was a 0 on my calculator. One thing for sure, do not just use 169. Always carry at least 4 sig figs. Okay. Now, here's what would be considered the tricky part for this. So my 161.6 kilojoules per mole is the delta H reaction for this reaction, right? That I think we hopefully understand. It's positive, and so this is an endothermic reaction. And for endothermic reactions, that means that the energy or the heat has to go into the reaction. And from the lecture outlines, what we also said is what heat goes into the reaction. So heat is a reactant. So what we can do is this 161.6 kilojoules can go as a reactant. And the reason I do that is because in my, what would be considered my mole to mole ratio, I am now going to use this coefficient for 2 moles barium peroxide. With the 161.6 kilojoules. And what's confusing about this is, if I look at this, it's now 161.6 kilojoules per 2 moles of barium peroxide. And here it's listed as 161.6 kilojoules per mole. And I get it, that's pretty confusing. But that's why this mole to mole ratio, it's important that you put this number in your reaction. Because if it's in your reaction, we can now say there's 161.6 kilojoules, and that is, so when we do our mole to mole ratio, is for 2 moles of barium peroxide. It's actually for 1 mole of oxygen, O2. And another way to do it is, this number is per 1 mole of oxygen, and only because this has a 1 coefficient. I don't know. I actually shy away from that. I go towards this process. But what will happen is, if you forget this 2 here, your answer will be off. And anyway, that's potentially why. So now I have all of my work set up, and I just have to multiply it out. I get 43.5 divided by 169.3 times 161.6 divided by 2. And I would say I am going to round this to 20.8 kilojoules. That's my units. Though if you enter it into the homework system as 20.76, it will also, of course, accept it. Any questions about that?